Hello and welcome to Earthquake Tip number 30. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 30 is on what is important in foundations of earthquake resistant buildings. Having discussed in detail the earthquake behavior and resistant measures for the buildings above ground, that is superstructure, now let's understand about the foundations of the building below the ground, which is substructure. First and foremost thing is selection of site for earthquake resistant buildings. The site of the building should be free from any collateral damage due to earthquake related impacts. Therefore, the ideal sites are away from potential fault rupture zone, away from the level of inundation under tsunami waves generated in the adjoining portion by earthquakes, as you can see in this figure 1, beyond the forest and wooded areas with potential fire hazards arising from earthquakes, and free from detrimental earthquake actions on the ground like liquefaction, settlement, and lateral spreading. Now let's look at this figure number 2. Even if site is away from collateral damage, steep slopes or vertical cuts in natural hills, which are otherwise safe under other loads acting on them, can slide during earthquakes. Vulnerable soil embankments can also slide or spread laterally due to liquefaction. Other earthquake hazards at hill slopes include rolling stones and debris. When the ground shakes underneath buildings with elongated plan or long span structures such as suspension bridge, the motion at different supports may not be synchronous. Different shaking of such structures at their support induces additional effects and should be accounted for in the design. Now let's understand through this figure what is the effect of ground shaking on building. Even if local strata underneath a proposed structure is stable, ground shaking may be modified when earthquake waves propagate through the soil overlying rock layers. This phenomena is referred to as site effect. Means even when shaking at the base rock is moderate, the motion at the site may be amplified by soil above rock, and this needs to be accounted for in the design. Site effects were first noticed in 1819 Kutch earthquake in India. It was also very prominent during 1985 earthquake that affected Mexico. Ground response was amplified by up to 7 to 8 times at building sites located on uh, lake bed, in contrast to those located on hard rock, as you can see in figure 3a. These lake beds or soft soil are similar to a ball of jelly. Imagine a building resting on hard rock vis-a-vis soft soil. The shaking gets amplified on soft soil. Now let's look at this figure 3b, which shows peak ground acceleration, that is PGA. It is a measure of severity of ground. During 1985 earthquake, PGA at the soft soil, which is shown in red, was significantly larger than at the rocky side, which is shown in green. Let's conclude it now. Amplification of ground motion depends on soil properties, which comprises of its shear modulus, damping, soil layers and layer properties, saturated versus dry soil, loose versus dense soil. It also depends on ground motion characteristics. In general, Stiff soils have lower amplification while soft soils higher. Seismic design codes provide response design spectra for underlying soil strata for different soil types. Having understood the effect, let's dwell upon seismic design of foundation. You will agree with us that no structure can perform well if does not have a good foundation supported on strata that is stable during earthquakes. All principles applicable in foundation design of structures subjected to gravity load are also applicable in foundation design of earthquake resistant structures. Concept of foundation engineering like bearing capacity, settlement criteria are also relevant in earthquake resistant buildings. Thorough geotechnical investigations at the site are must for design projects. In addition to traditional standards and cone penetration tests, other in situ tests such as shear velocity test and pressure meter test may also be performed while designing earthquake resistant structures. Depending upon the geotechnical conditions and structural configuration and loads, a suitable type of foundation must be chosen. If soil type is hard, isolated footings may suffice under individual column, but these foundation must be tied to each other with beams at top of footings or within the footing depth to resist relative movements between column base, as you can see in this figure. On the other hand, if soil underneath is soft, other foundation type may become necessary, that is raft foundation or pile foundation. But if the soil is susceptible to liquefaction, either ground improvement must be undertaken or the foundation must be carefully designed such that it can carry the load even after vulnerable soil layers have liquefied, as you can see in this figure. In case of pile or well foundation, layers susceptible to liquefaction should be neglected in estimating stiffness and strength of soil system, as piles bypass these layers. In case of lateral spreading, investigation beyond the property boundaries of the building under consideration may become necessary, especially when plots are small. Also, lateral thrust offered by liquefied soil layers must be included in estimating force demand on foundations. At last, let me tell you that it is difficult to inspect and repair foundations after a severe earthquake. Further, damage to foundations can be detrimental to the stability of a structure. Therefore, in earthquake-resistant design, column damage in columns is preferred over foundation damage during strong shaking. This can be achieved by adopting capacity design concept, which was explained to you in earlier tips. That means the foundation system needs to be designed for loads higher than ultimate flexure capacity of columns or of structure walls. This is all about earthquake tip number 30. You can download this tip from www.bmtpc.org. The next earthquake tip, that is tip number 31, will be on why do buildings sink into the ground during earthquakes. Thank you.